Alright, so first we're going to go over example 3 from chapter 5.2. So hopefully you worked on this or try to work on this at home. But now we're going to go through it in case you got stuck or have questions. Okay, so I'm going to work with the left side first. So we have cotangent of alpha minus cosecant of alpha over cotangent of alpha plus cosecant of alpha. Okay, so one of the tricks in the hints of how to verify these identities is to turn everything into terms of sine and cosine. So let's try to do that first. Okay, so cotangent alpha in terms of sine and cosine, we can rewrite that as cosine alpha over sine alpha. And then cosecant is the same as 1 over sine alpha. And if you don't know, this letter right here is called alpha. It's the Greek letter for A. Okay. Alright, so now we have our numerator. Let's talk about the denominator. So we have cotangent again, so we can rewrite cotangent of alpha as cosine alpha over sine alpha. And then here we have cosecant again, but we just have a plus here instead. So we have 1 over sine alpha. Alright, so since they have the same denominators, that we can actually add them together. So we have cosine alpha minus 1 over sine alpha. That's our numerator. And then in our denominator we have cosine alpha plus 1 over sine alpha. Alright, so then I'm going to rewrite this. Instead of division, I'm going to write it as multiplication times the reciprocal. So our numerator, we have cosine alpha minus 1 over sine alpha. And then that division is the same thing as multiplying by the reciprocal of the denominator. So then we have times sine alpha over cosine alpha plus 1. Alright, so then the sign is going to go away, so we're left with cosine alpha minus 1 over cosine alpha plus 1. Alright, so this is what we have so far. Alright, so our next step is we're going to try to figure out what are we looking for. Okay, so what we're trying to get is this right side. Okay, so we want to try to get sine in the denominator. Okay, another one of the tricks in the hints for verifying identities, number 6, was if you have something of this form, then you can multiply by cosine alpha minus 1 to get one of the Pythagorean identities. So if we use that trick, then we can get the sine squared that we're looking for. Okay, so that's why we're going to multiply the top and the bottom by cosine alpha minus 1. Okay, so by doing this, our denominator is now cosine squared alpha minus 1. Alright, and then our numerator, so we have to FOIL both of these out. So we're going to get cosine squared alpha minus 2 cosine alpha plus 1. Okay, so looking at this denominator right here, that is the same. So our Pythagorean identity is sine squared theta plus cosine squared theta equals 1. And if we subtract cosine on both sides, then we have sine squared theta equals 1 minus cosine squared theta. Okay, but we have cosine squared theta minus 1. So we do negative sine squared theta equals negative 1 plus cosine squared theta, which is the same thing as cosine squared theta minus 1. Again, just like I said in class, there are other ways to solve this. We could have subtracted sine on both sides to get 1 minus sine squared theta, and then subtracted the 1 on both sides. Either way, you should still get the same answer. So now instead of cosine squared alpha minus 1, we have negative sine squared alpha. Okay, so our denominator now is negative sine squared alpha. And then for our numerator, we're going to keep it the same. I'm just going to rewrite it in the order as the numerator given in the identity above. Okay, so, but notice that this is the same. So cosine squared alpha is here, minus 2 cosine alpha here, and then plus 1. Okay, so all I'm doing is just rewriting the top. Alright, so that's how you do it if you start from the left side. So let's talk about if you started from the right side. Alright, so on the right side we start with 1 minus 2 cosine alpha plus cosine squared alpha over negative sine squared alpha. Alright, so the first thing I'm going to do is rewrite my numerator in descending order. So this is a technique from college algebra. So rewriting in this order, then I can factor my numerator. Okay, so from here, this numerator is cosine squared alpha minus 2 cosine alpha plus 1. This is something you're just going to have to be able to see and know that this is going to factor into cosine alpha minus 1 times cosine alpha minus 1. Okay, this is one of those algebraic identities that were given on the hints for verifying identities. So it should be something that you can easily recognize and break down. If you're not sure if this is the correct, you can always multiply it back out and make sure you got what you started with. But it's something that you just need to be able to identify. Okay. Alright, so then talking about the denominator. So we have negative sine squared alpha. So this is going to come from the Pythagorean identity. So if we just look back up here, we can see that negative sine squared alpha is equal to cosine squared alpha minus 1. Okay, so we're just going to replace the denominator with this side. So we have cosine squared alpha minus 1. Okay, so I'm just going to rewrite the numerator. Okay, and then we're going to talk about the denominator. Okay, this is another algebraic identity that you need to know. This is the difference of perfect squares. Okay, so cosine squared alpha minus 1 is the same as cosine alpha plus 1 times cosine alpha minus 1. Okay, so that's another identity that you need to be able to recognize. Alright, so from here, these two are going to go away. They're going to, in quotation marks, cancel each other out. And then we're left with cosine alpha minus 1 over cosine alpha plus 1. Alright, so from here, the next step gets a little bit tricky. You have to think about what you're actually looking for. So the left-hand side that we're looking for has cotangent and cosecant, okay? So we need to know what relates cotangent and cosecant to cosine. Okay, so what cotangent and cosecant have in common would be the sine function. Okay, so we know that if we divided cosine by sine, then we get cotangent. And if we divide 1 by sine, then we get cosecant. Okay, so we want to multiply the numerator and the denominator by 1 over sine alpha. Okay, so I basically just divided the numerator by sine alpha and the denominator by sine alpha. Okay, but make sure when you're multiplying like this that you have the same thing on the top and the bottom, because this is equal to 1, so it's not actually changing any of the values in your identity. Alright, so if we do this, we have cosine alpha over sine alpha minus 1 over sine alpha. And then cosine alpha over sine alpha plus 1 over sine alpha. Okay. And then from here you can see that this turns into, so we have cotangent alpha minus cosecant alpha, and then again cotangent alpha, and then plus cosecant alpha. Okay, and then this gives us our left side that we were originally looking for. So when you're trying to find out what identities to use, just look at the other side at what you're trying to get, and then try to find a relationship between those two identities in order to find the one that works for you. Okay. If you're confused or you have questions about this problem, email me. I will also send out, you'll have extra practice on your homework. I am also going to send out an email later today for extra practice on chapter 4, but we will also have extra practice on these identities in our review and the review I do for test 2. Okay. But this is the end of 5.2, so I'm going to go ahead and start talking about 5.3 today, which are new identities that we are going to be using. Alright, so 5.3, we're going to talk about sum and difference identities for cosine. So sum and difference identities for cosine. Cosine of A minus B is not the same thing as cosine A minus cosine B. Okay, so for example, if A is pi over 2 and B equals 0, then cosine of A minus B would be cosine of pi over 2 minus 0. So that would be cosine of pi over 2, which is equal to 0. Okay. So cosine A minus cosine B, that would give me cosine of pi over 2 minus cosine of 0. Well, cosine of pi over 2 is 0, and then cosine of 0 is 1. Okay, so this would give me a negative 1. Okay, so notice that these two are not equal, so you cannot split it up that way. So that's where our new identities come in. Okay, so for the difference identity, so for cosine of A minus B, that's equal to cosine A times cosine B plus sine A times sine B. And then the sum identity for cosine, cosine of A plus B is cosine A times cosine B minus sine A times sine B. Okay, so notice that the function and the a and b are the same in both of them. It's the sign that's different. So for cosine, so later on we'll talk about sine and tangent, but for cosine, the difference, so minus is actually going to use a plus, and then the plus is going to use a minus. Okay, so you just need to remember one of these forms and then when to use plus or minus. Alright, so let's talk about examples. Okay, so we want to try to use these identities. So it says find the exact value of each expression. So the exact value means to make sure that you are not rounding at all, and that your answer is usually going to be in a fraction or radicals or maybe radians, depending on what type of answer you have. Just make sure that you are not cutting off and rounding a decimal. Okay, we want an exact answer. Alright, so we have cosine of negative 75 degrees. Okay, so to use these identities, we want to rewrite them in degrees that we readily know the answer to. Okay, so 75 degrees, so negative 75 degrees would be the same thing as cosine of negative 30 degrees minus or plus negative 45 degrees. Okay, we know what cosine of 30 degrees and what cosine of 45 degrees is, so these would be numbers easier to work with. Okay, so we have cosine negative 30 plus negative 45. Okay, so we do have the plus here in the middle, so we are going to use the sum identity for cosine. Okay, so let 30 represent A, negative 30 is A, and negative 45 is B. Okay, so we have cosine of negative 30 degrees times cosine of negative 45 degrees minus sine of negative 30 degrees times sine of negative 45 degrees. Alright, so the next thing that we're going to do is use our even and odd identities. Okay, so cosine is an even function, so that means that cosine of negative 30 degrees is the same as cosine of 30 degrees. So I can rewrite this as cosine of 30 degrees times cosine of 45 degrees. Okay, and then I'm going to leave this minus out front, and then let's talk about sine. Okay, sine is an odd function, so that means that sine of negative 30 degrees is the same as negative sine of 30 degrees. Okay, so that would be negative sine of 30 degrees times negative sine of 45 degrees. Okay, so notice here that we have a negative times a negative, so this is going to become positive. So this is why I pulled that negative out front, so that you don't get confused when you're changing the signs here. So this negative times a negative gives us a positive, so we have cosine of 30 degrees times cosine of 45 degrees minus sine of 30 degrees times sine of 45 degrees. Alright, so now we're just going to plug in the values. Okay, so cosine of 30 degrees is square root of 3 over 2. And at this point, since we've already tested this information of how to find this value on test 1, you can actually just plug it into your calculator if you need to. Okay, cosine of 45 degrees is square root of 2 over 2, and then minus So sine of 30 degrees is 1/2, so 1 over 2. And then sine of 45 degrees is square root of 2 over 2. Okay, so this is going to give me square root of 3 times square root of 2, square root of 6, and then 2 times 2 is 4, and then minus square root of 2 over 4. Alright, so that's the same thing as square root of 6 minus square root of 2 over 4. Okay, so this would be your answer. You can't simplify anything further than that. One other thing, I would go back and check to make sure that you did your work correctly. So you can check and see, does cosine of negative 75 degrees equal square root of 6 minus square root of 2 over 4? Okay, remember, we are working with degrees here, so your calculator needs to be in degree mode. So cosine of negative 75 is equal to square root of 6 minus square root of 2 over 4. Right? So then that one is done. Okay, so B, we have an example in radians. Okay, so we have cosine of 17 pi over 12. Okay, so a couple things here. If you wanted to change it into degrees, you could. If you want to do it that way and then split it up into A plus B, or you can keep it in radians and do it that way. So what you're looking for when you split it up in radians is something that's going to give you a 30, a 45, or a 60 degree angle. It may not necessarily be 30, 60, or 45 degrees, but it may have a reference angle that is. Okay, so you'll see what I mean by that. Alright, so we're going to write this as cosine of 2 pi over 12 plus 15 pi over 12. Okay, so make sure I add those back together. I do get 17 pi over 12. Okay, so if I simplify these values, so 2 pi over 12 would give me pi over 6. And then if I simplify to 15 pi over 12, I get 5 pi over 4. Alright, so pi over 6 is 30 degrees. Okay, 5 pi over 4 is 225 degrees. Okay, and remember, 225 degrees, that would put us in quadrant 3. So if I was to find a reference angle for 225, I would subtract 180 degrees. So if I subtract 180, I get a 45 degree angle. Okay, so these are the type of angles that you want to find. You'll get more familiar with what you're looking for once you practice these, okay? Alright, so now we have it split up. So we're going to let pi over 6 be A, and then 5 pi over 4 is B. Okay, and we are adding, so again, we're going to use a sum identity for cosine. Alright, so we have cosine of pi over 6 times cosine of 5 pi over 4 minus sine of pi over 6 times sine of 5 pi over 4. Okay, and we don't need to use even or odd identities for this case because all of our arguments are positive. So now we can just go ahead and plug in the values for each of our functions. Alright, so cosine of pi over 6 is going to give me square root of 3 over 2 times cosine of 5 pi over 4 is going to give me negative square root of 2 over 2. Again, make sure that your calculator is in radians, okay? Because we're talking about radians now, so make sure you've changed the mode over. Alright, so minus sine of pi over 6 is 1 over 2, and then sine of 5 pi over 4 is going to give me negative square root of 2 over 2. Alright, so we are just going to simplify. Okay, so square root of 3 times negative square root of 2, that's going to give me negative square root of 6 over 4. And then I'm going to have plus square root of 2 over 4. Alright, so that's the same thing as having, I'm going to write square root of 2 first. So square root of 2 minus 6 over 4. Okay, so we want to go back and check. Does, what was it, cosine of 17 pi over 12 equal negative square root of 6 plus square root of 2 over 4? Yes. Okay, so either way, if you wrote these are both equal. So I would take either one if you wrote them that way on the test. Okay, they're both the same answer. Alright. So let's talk about C. Okay, so C, we're going to go the opposite way. So you'll just need to know by looking at this what type of identity that you're going to use. So when it's in this form, a trig function multiplied by a trig function, plus or minus a trig function multiplied by a trig function, it's going to be a sum or difference identity. And then it'll be based on whichever trig function you are looking for. Okay, so here we have cosine of 173 degrees times cosine of 83 degrees plus sine of 173 degrees times sine of 83 degrees. Okay, so once you learn the other sum of difference identities, you'll know that this is for cosine. Because of how the sum of difference identity is set up for cosine. Both cosines are here and then sines are here, and you'll know what I'm talking about once we learn the other ones, okay? So these numbers have to be the same, okay, because one has to be A and one has to be B. Okay, so if 173 degrees is A and 83 degrees is B, so we have cosine A times cosine B plus sine A times sine B. Okay, so this is the difference identity for cosine. So this is equal to cosine of A minus B. Alright, so if we just plug in our values for A and B, we have cosine of 173 degrees minus 83 degrees. Okay, well 173 minus 83 is going to give us 90. So we have cosine of 90 degrees. And then cosine of 90 degrees is going to give us 0. Okay, so our answer would be 0 for this problem. Alright, so cofunction identities. So we've previously talked about these, so you should know what they are. And again, somehow there should be a space right here,
Yes.
but it didn't print out. Alright, so cosine of 90 degrees minus theta. Okay, so we know this is sine theta. Just for a reminder, do not mix these up with reciprocals. Okay, so reciprocals. Okay, so they're not the same pairs when it comes to reciprocals and cofunction identities. Okay, so sine of 90 degrees minus theta, that's going to be cosine theta. And then tan of 90 degrees minus theta is cotangent theta. Cotangent's cofunction is going to be tangent. Secant's cofunction is cosecant theta, and then cosecant's cofunction is secant theta. Okay, so the thing about cofunctions, remember, this is how they relate, that their angle is equal to their cofunctions with 90 degrees minus the theta. So their two angles added up equals 90 degrees. You can do the same identities if you are in radians. Okay, so 90 degrees in radians is pi over 2. Okay, so it works the same way using pi over 2. So let's talk about how we're going to use these. Okay, so we want to find a value of theta or x that satisfies each of the following. So for A, we have secant theta equals cosecant of 62 degrees. So we want to find out what value of theta will make this equation true. Okay, so in order to use the cofunctions and make this true, theta plus 62 degrees must equal 90 degrees. Okay, so you can write it as theta plus 62 degrees equals 90. Or you can write it as 90 degrees minus theta equals 62 degrees. Okay, these are both the same thing, it's just the format of whatever works for you when you're solving these problems. So the second format comes straight from the cofunction identity, but sometimes this one may make a little more sense from previous sections that you know theta plus 62 has to equal 90 degrees. So either way, you get the same answer. So we have, if we use this one, we have theta equals 90 degrees minus 62 degrees. So that means that theta is equal to 28 degrees. Okay, so that means that secant of 28 degrees is equal to cosecant of 62 degrees. Okay, and then you can always double check and make sure 62 degrees plus 28 degrees equals 90 degrees. Alright, so same concept for B. Tan and cotangent are cofunctions. So that means that theta plus negative 54 degrees has to equal 90 degrees. So we have theta plus negative 54 equals 90 degrees. Or theta minus 54 equals 90 degrees. Gives you the same thing. Okay, or you could write 90 degrees minus theta equals 54 degrees. Okay, so either way, whatever works best. So as long as you're getting the correct theta. Okay. Alright, so from here, if we add 54 to both sides, we have theta equals 144 degrees. So that means that tangent of 144 degrees equals cotangent of negative 54 degrees. Okay, and then you can always double check. Negative 54 degrees plus 144 degrees does equal 90 degrees. Okay, and then C. So now we have a, now we're given a trig function in radians. So we have cosine of x equals sine of 7 pi over 6. Okay. Okay, so working this problem. So we know x in 7 pi over 6, so x plus 7 pi over 6 equals pi over 2. Okay, so we're using pi over 2 now instead of 90 degrees. They are the same measure, just one's in radians and one's in degrees. Okay, so you can write it that way, or if you're going back to this form, you would have pi over 2 minus x equals 7 pi over 6. Okay, so either way you want to write it, same idea. Alright, so I'm going to use this top one. X plus 7 pi over 6 equals pi over 2. So it's just saying this angle plus this angle. So this angle plus this angle equals pi over 2, which is 90 degrees. So we're just going to subtract 7 pi minus 6 on both sides, or 7 pi over 6 on both sides. So we have pi over 2 minus 7 pi over 6. Okay, so if I rewrite pi over 2 to have the same denominator, that would be 3 pi over 6 minus 7 pi over 6. And then 3 minus 7 is going to give me negative 4 pi over 6. And then if I simplify this fraction, I get negative 2 pi over 3. Okay, so that means that cosine of negative 2 pi over 3 is equal to sine of 7 pi over 6. Okay, and then always go back and check, does negative 2 pi over 3 plus 7 pi over 6 equal pi over 2? Okay, you could have also turned 7 pi over 6 into degrees first, and then just did x plus the degrees equals 90 degrees. But just make sure that whenever you actually give your answer, that you change it back into radians if radians is what you were given to work with. Alright, so example 3. Okay, so example 3 says write cosine of 90 degrees plus theta as a trigonometric function of theta alone. So what it means by that is the argument here should only be theta. Okay, so there shouldn't be any other values, degrees or radians in the parentheses. Okay, so a function of theta alone. Alright, so we have cosine of 90 degrees plus theta. Okay, so if we go back to the sum and difference identities for cosine, we can see that this is a sum identity for cosine since I have addition right here. Okay, so if I let 90 degrees be A and let theta be B, I can rewrite this as cosine of 90 degrees times cosine of theta minus sine of 90 degrees times sine of theta. Okay, so remember that this is always the opposite for cosine. Okay, so sum identity, you have a minus. Alright, so cosine of 90 degrees is 0. So we have 0 times cosine theta. And then sine of 90 degrees is 1. So then we have minus 1 times sine theta. Okay, so that's 0. So we're left with negative sine theta. Okay, so that means cosine of 90 degrees plus theta is equal to negative sine theta. Okay, so that would be our answer. And so here we have a trig function of theta alone. Okay, so that's what it's asking for. Alright, so example 4. Suppose that cosine S equals 15 over 17 and sine of t equals negative 24 over 25. Okay, both S and R are in quadrant 4. Find cosine of S minus t. Alright, so first off, cosine of S minus t. Okay, so this is going to give us the difference identity for cosine. So that means cosine of S minus t is equal to cosine S times cosine t plus sine S times sine t. Okay, so let's look at what we know. We know cosine S, so I can write 15 over 17 here. But we don't know cosine t. Okay, we only know cosine S. So I'm just going to rewrite cosine t. Okay, and then we don't know sine S. We only know sine t. So I'm just going to rewrite sine S. And then sine t is negative 24 over 25. Alright, so how do we find cosine t and sine s? So you can use different methods. So we have now learned a few different things. So it's dependent on what you want to do. Okay, so if you're going back to previous chapters and things that we learned on test 1, you can use the fact, okay, so cosine is x over r. Okay, so it means x would be 15 and r would be 17. And then you could find the y value by using the Pythagorean identity. Okay, and remember that it is in quadrant 4. So quadrant 4 will tell you what your value, your y, is going to be negative. Okay, and then you could do the same thing. So this would give you y, and then you could find sine s as y over r. And then you could do the same concept for cosine t using sine t equals y over r, so that's negative 24 over 25. And then using that to find x. Okay, so x is going to be positive in quadrant 4. So this way you use the Pythagorean theorem in order to find the other values that you're missing. Okay, so that's one way to do it. The other way you can do is use Pythagorean identities. Okay, so here's the Pythagorean theorem, but you can also use Pythagorean identities. Okay, so let's go down here some. Okay, so I have cosine squared s plus sine squared s equals 1. Okay, well we know cosine of s, so if we plug that in, we have 15 over 17 squared plus sine squared s equals 1. Okay, so that means that sine squared s equals 1 minus 15 over 17 squared, which is going to give me 225 over 289. Okay, so I just squared 15 and then I squared 17. Alright, so if I do 1 minus this fraction, I'm going to get sine squared s is equal to 64 over 289. And then take the square root of both sides. Okay, so the square root of 64 is 8, and then the square root of 289 is 17. Okay, and then I need to choose my sign based on what quadrant I'm in. So we're in quadrant 4, and sine is negative in quadrant 4, so this is going to give me negative 8 over 17. Okay, so I can plug this in for sine s. Okay, so we're going to do the same concept for cosine t. Okay, so cosine squared t plus sine squared t equals 1. So that means that cosine squared t is equal to 1 minus sine squared t. Okay, sine of t is negative 24 over 25, and we want to square that. So that's going to give me 1 minus 576 over 625. Okay, so 24 squared and then 25 squared. Make sure that you're putting your negative on the inside of the parentheses when you square it. Anytime you square something, it should come out positive, okay? So this minus is coming from right here, but this minus, when you square, becomes a positive. Okay, so make sure you're watching your signs. Alright, so 1 minus 576 over 625. So that's going to give me cosine squared t equals 49 over 625. So I need to take the square root of both sides. So 49 over 625. So square root of 49 is going to give me 7. And then the square root of 625 is going to give me 25. Okay, and then the last thing I need to check is it positive or negative? Okay, so again, we're in quadrant 4. Okay, so cosine is positive in quadrant 4. So 7 over 25 would be the answer for cosine t. Okay, so now we can take these values and plug them back into our equation. Okay, so we have 15 over 17, and then cosine t is 7 over 25. So I'm going to plug that in right here, 7 over 25, plus sine s, so sine s is negative 8 over 17, times negative 24 over 25. Okay, so you can use either of these methods to find the missing values, the missing trig functions that you need. Whichever one comes easier to you, use those. You will have these functions whenever you're on the test, so it may be easier just to plug into these. Just make sure you're getting the correct answers. Alright, so let's multiply these out. So we have 105, so 15 times 7 is 105, and then 17 times 25 is going to give me 425. And then negative 8 times negative 24 is going to give me a positive 192. And then again 425, because we have 17 times 25 again. Alright, so that was going to give me 297 over 425. Okay, and this would be the answer. Okay, so whichever method works best for you. Alright, last problem. Okay, so example 5. Verify that the following equation is an identity. Okay, so notice that we have addition inside of our argument. Okay, so we're going to use one of our new identities for sum and difference. Okay, we don't know an identity for secant. We only know, as of now, a sum and difference identity for cosine. Okay, so that means that the first thing I want to do is somehow change secant into terms of cosine. Okay, so we're going to work with this left side. Okay, well, I know that secant theta is equal to 1 over cosine theta. So that means that secant of pi plus x is equal to 1 over cosine of pi plus x. Okay, so now that we have cosine, we can use the sum identity for cosine. So I'm going to rewrite this. So we still have 1 in the numerator. And then we're going to let pi be the value for A, and then x is going to be the value for B. Alright, so we have cosine of A, so cosine of pi times cosine x minus sine of pi times sine of x. Okay, cosine of pi is -1, and sine of pi is 0. Okay, so if sine of pi is 0, 0 times sine is going to give me 0. So I'm left with 1 over -1 times cosine x, okay, or negative cosine x. Okay, and remember, we're trying to get the right side. So the last thing I need to do is use this reciprocal again, the reciprocal identity, and change this to negative secant x. Okay, and then that would be our identity. So for this case of verifying identity, you could probably see that it's easier to use the left side to verify than it would be to use the right side. Okay, so that's why it says to generally go for the harder side and make that look like the other side that you're working with. Alright, so that is it for chapter 5.3. So we'll start 5.4 once we get back from spring break. You do have the 5.2 and 5.3 homework is due the Tuesday morning after spring break at 9 a.m. So that would be March 24th at 9 a.m. And you also have the quiz that goes along with that. You're more than welcome to go ahead and work on it and get it done, so then you don't have to worry about it over spring break. So the choice is up to you. Like I said, I will send out an extra worksheet for chapter 4 so you can practice on the sine and cosine, tangent, cotangent functions, and then finding amplitude or period, or looking at translations. So I'll get that sent out later today. But other than that, y'all have a good spring break, and hopefully I will see you afterwards.